Hi everyone. So today we are going to solve the problem find the kth smallest pair distance. So let me go through the question first. Given an integer array nums return integer array nums and integer k return the kth smallest distance among all pairs. Num I and num j where okay. So we are given a array of nums and an integer k. So we just simply have to return kth smallest distance among all the pairs. So first of all, we have to. So I hope you understood the question. So if you have, then the first brute force approach could be like first of all we have to find all the distances among all possible pairs in the given given array. Let's take the example 1 comma 3 comma 1. Sorry, 1. So the possible pairs are 1 comma 1 and then 1 comma 3 3 comma 1. So distances are 0, then 0, here it is 2 and here it is 2. So what was the k value? The k is 1. So first kth smallest distance is 0 as yeah, that's the that's what we written. So the brute force approach will be like this. I have already coded it, so let me explain this. But the brute force approach is to find all the pairs possible, like here for example, from I'm starting from first index and finding all pairs that are possible with the first index, and then same with the second index, third index and all. Also, while I'm taking the possible pairs, I'm calculating the distance between them and adding the distance to a priority queue, which is a maximum priority queue that keeps the maximum element at the top. So I am adding that distances to this priority queue, and if the size of priority queue increases is more than k, then we are simply going to remove the element because we just want the kth smallest, that is kth smallest distance. So k elements are enough to be in the priority queue. So that's what I have done here. Uh, this works fine, but there is problem. The possible length k is possible up to n square by 2. That is, if we try to submit this solution, it will give us a time limit exceeded error or space limit exceeded. So we have to think of a see. I got the memory limit exceeded. So the brute force approach won't work here. So we have to imply some optimal solution. So first of all, to minimize the calculation of distance, we first of all we have to sort this nums array so that distance calculation will be simple. Because let me explain this through drawing. Let's take the first one as example. Okay, one one let me zoom in a bit. 1 comma 3 comma 1. So this is the so least possible. Let me short this array first of all, that is 1 comma 1 comma 3. So from here we can see that the least possible distance is 0, and also maximum possible distance is the difference between the max element and min element. In a sorted array we can simply find it out, that is 2. So our kth smallest distance lies between this. So from the sorted array we can get the lower bound and upper bound of the distances. So to find the kth smallest element, we simply have to do the binary search, the modified binary search. We have to first of all take the midpoint. Here midpoint will be 1. So we have to take one and then compare and then compare if it is the uh, kth smallest element or not. Also, let me explain this through coding. So how we are going to do? So first of all, we take the mid one. So then we have to find out the how many pairs are having distance less than or equal to 1. So let me find it out. So 1 minus 1, that is one pair. We have 1 comma 1, that gives the distance less than 1. We just have one pair, so it will be 1. Got the. So let me go to the previous tab. uh, Here, so the k value is 1. So smallest distance pair is 1 comma 1 and its distance is 0. So since it is less than or equal to uh, so we have one pair that has the distance less than or equal to 1. So what we do is we change the upper bound to midpoint. So now our uh, the range will be 0 comma 1. So now the midpoint of 1 comma 0 is 0. So we'll check how many points are there where their distance is less than or equal to 0, that is 1 comma 1. So again the distance is 1 1. So we again try to reduce the lower bound to 1 0 0 comma 0 will be our range. So here our lower bound or upper bound meets at one point, so we simply have to return the left or the lower bound. So let me go through and code this up. Uh, I'm gonna remove this base case, I mean the brute force approach, and then start coding the optimal solution. So first of all, let's sort the arrays for nums first, and then have the get the size of nums into an equal length, and then initialize two bonds. I'm gonna call it left and right. You can call it lower bound or upper bound. Left 0, right. So the right one will be difference between the first element in the sorted nums array and last element. So I'm gonna nums of n minus 1 minus nums of 0. So this will be the highest bound. So I'm gonna initiate a binary search. Binary search. So let's start with the base case, and this will run until left is less than right. Once they both meet, we got the answer. So first of all, we're gonna calculate the midpoint, left plus C. So for the simplicity, I'm gonna take the left as L and right as R, because it is taking time to type this. Yeah. Left and right, right minus left divided by 2. Now, now we're going to get the count. This will be the number of pairs that are having distance less than or equal to mid. So for this we are going to have a helper function that fetches us this. So for to this function we are going to pass nums and mid. Sorry, mid. Uh, and if the count is greater than or equal to k, then we are going to change the upper bound to right to mid, because we are going towards the right side, so we have to reduce the bound to the left side so that we get the equal to k solution. Let me show here. So here, uh, uh, sorry, else if left equal to mid plus 1. If this is not the case, then the count will be less than k, then the answer will not lie on the left side, so we are updating the lower bound to mid plus 1 so that we can check in the right part of the array. This is how we reduce the space, and when left crosses right, we are simply gonna return left, that because we reached the solution. So this will be the essential by modified binary search. We have to complete this function, helper function now. So this function, I'm going to initiate this helper function, public. Okay, one more thing, I'll try to keep my function as private, and then this is going to return an integer as output, that is count, and function name is helper. This takes input of array, that is nums, and integer mid, that will be the number of pairs or distance. So in this, first let me calculate the length of nums array, and also initiate the count to 0, return count, and from here let me initiate a integer j, suppose. Now I'm going to initiate a loop int I equal to 0, I less than and I plus plus. So what we are going to do is we are going to slide in nums array between between indexes, that is one is I and j, so that we find the distance between this I element and jth element at the jth index, and try to make the distance less than or equal to mid, so that you can find the count of how many elements, how many pairs are there, such that the distance is less than or equal to mid. For that I'm going to do this like a sliding window until j is less than and nums of j minus nums of I is less than or equal to mid. So until then I'm gonna just increment the j, and then add the count to count element. So the count will be j minus I, because uh, the number of elements between I and j will be j minus I plus 1. We are adding plus 1 because I can possibly be 0. So if we have 0 and 1 index, then the subtracting 1 minus 0 gives us 1 only, but there are actually two elements, that's why we add the 1 as well, and then simply we are going to return count. So let me explain this part clearly. So what we are doing here is, so let me take the example 113 1 comma 1 comma 3. So I'm going to initialize I and j here, I and j here. So I'm going to check distance between I and j, which is 0. So mid will be 1, right? So since the distance is less than j, I'm going to increment j. Now j will be here. Again I'm going to check the distance is 0, still it is less than or equal to mid, so I'm going to increase j to 3. Now the distance between 1 and 3 is 2, which is greater than mid, so I'm going to stop here and return count as j minus I, that is 1 minus 0 plus 1, that will be count will be 2. I hope you got the understanding. So let me just run this solution. Okay, sorry, simple typing mistake. Let me, so we got it wrong answer. So we got one wrong case, because that's because here I forgot to uh, minus the one, instead I added one, so that's the issue. So let me submit again, run the solution again. Yeah, now it's working fine. Instead of adding, we have to subtract it. That's what I made mistake. Yeah, now it's working. So the now coming to the time complexity and space complexity. So the first of all, the sorting array takes n log n time, and the binary search here, it takes the uh, time complexity of uh, mm, and the other is binary search complexity. So here we're depending upon the bound is between lower and so r is essentially the maximum distance, so the complexity will be n log m, where m is the maximum distance. So the time complexity will be n log n plus n log m, where m is the maximum distance. And also space complexity, so we haven't used any space complexity here. Maybe here, while sorting the array, we might have required still we might have required some space. So I'm gonna take the space as a n log n, or log n space. Let's just call it as a space that is required for sorting the array. That's all for today. Thank you.